Hello everyone. Today we are starting the topic periodic table. Periodic table. Table. In this topic, total 7 subtopics are there. First one is history of periodic table. Periodic table. Then second topic is finding period block group of an element. Finding period block group of an element. Then third, Z effective and screening effect. Screening effect. Then fourth topic, atomic radius. Fifth, ionization energy. Sixth, electron affinity. And seventh, electron negativity. So total these 7 topics we have to cover as per our NEET and JEE exams. So here I will tell the which topics are very important for the JEE and NEET. If you see in the last 20 years, every year question is coming from the atomic radius, ionization energy and electron affinity, but atomic radius is most important in this topic. If you want to do periodic table, atomic radius should be done very clearly. And in history of periodic table, there is not much to study. 5 topics are there in history of periodic table: Lavoisier classification, Davenier's triad, Newland's law of octave, fourth one Lothar-Meyer's curve, and fifth one Mendeleev's periodic table. Okay, history of periodic table. In this first topic we have to cover Lavoisier classification. Then second one Davenier's triad. Then third one Newland's law of octave. Fourth one Lothar-Meyer's curve. Fifth one Mendeleev's periodic table. There's not much theory in these 5 topics. As per JEE and NEET, you should clearly understand the Dabernier triad, Lothar-Meyer's curve, and Mendeleev's periodic table, because the question will be from this topic if they are asking from history of periodic table and classification. Okay, so Dabernier triad is important, Lothar-Meyer's curve is important, and Mendeleev's periodic table is important. Okay, so now we will start with the Lavoisier's classification. Lavoisier's classification. In Lavoisier classification, he was the first scientist who classified the elements. He gave 2 points. First, he classified all the elements in 2 categories only. He classified all the elements in 2 categories only. Then second important point in this, he classified elements in metals and non-metals. Elements in elements, first classification is metal, and then second non-metals. He explained that metals, all the electropositive elements are metals. And all the electronegative elements are non-metals. Electropositive means the element which can donate the electron and form cation, like sodium. Sodium can donate 1 electron and can form Na plus. As we know, the outermost shell in sodium, 1 electron is there, and electronic configuration is 2, 8, 1, total 11 electrons. So sodium can donate. So it was categorized as a metal. And non-metal, chlorine can take 1 electron and it can form chlorine anion. So it was categorized as a non-metal. As some elements got discovered which have metals and non-metal characteristics, Lavoisier's classification failed. Okay, failed. There's one point why it failed. As some elements got discovered which have metal and non-metal characteristics. Lavoisier's failed here. Now the second scientist came with the another classification, and second scientist was Daveniers, and Daveniers classified all the elements in triads. Second one, he was the second scientist who classified elements. He started arranging elements and he started grouping elements and made triad. So two important points in Daveniers triad. First, first one in that is elements arranged in increasing order of atomic weight. So he was the first scientist who arranged elements in increasing order of atomic weight. First point, elements arranged in increasing order of atomic weight. Then second point in this, the atomic weight of middle element is the average of first and third element. The atomic weight of middle element is the average of first and third element. In this classification, he gave example lithium, sodium, potassium. Lithium, sodium, potassium. Atomic weight of lithium is 7. Potassium is 39. So according to Daveniers, atomic weight of sodium is 7 plus 39 divided by 2. So 7 plus 39 is 46. Divided by 2 is equal to 23. So atomic weight for the sodium is 23, and it was right also. Then second example, you can see chlorine, bromine and iodine. Atomic weight of chlorine is 35.5. Iodine is 127. So average of this is 35.5 plus 127 divided by 2 equal to 81.2, and bromine's atomic weight was 80. So in the both cases it is satisfying. Now the drawback or failure of Daveniers triad. Okay, I am raising the second example, drawback or failure. In this, if you take fluorine, chlorine, bromine, atomic weight of fluorine is 19, bromine 80. So 19 plus 80 divided by 2, 99 divided by 2, it is coming 45, 49.5. But the atomic weight of chlorine is 35.5. So here it got filled. Okay, 3 elements triad, it is satisfying here. Okay, but the average of first and third is not giving the middle elements atomic weight. Now the third scientist came with theory, Newland. He came with the octaves theory. Newland law of octaves. In this, first point is same as Davenier. Elements are arranged in increasing order of atomic weight. In increasing order of atomic weight. So here it is satisfying the Davanier's theory, but the second point, every eighth element has same property like first element. Here it is different with Davenier. He was creating the triads, but he made the eighth elements groups. Second point, every eighth element has same property like first element. Like Indian classical music notes, sa, re, ga, ma, pa, dha, ni, sa. Sa is coming again after the 7. Sa, re, ga, ma, pa, dha, ni, and again sa. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Inert gas were not discovered at that time, so neon was not known. Sodium, then it will come sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, potassium, and calcium. So in this, he said the every eighth element, lithium is the first element, beryllium is second, third, fourth, 5, 6, 7, 8. Sodium is the eighth. So lithium has same property as sodium, and potassium also. Like this, in a one column, all the elements will have some property same as other elements. So, but this also got filled after the discovery of inert gases field. After inert gas discovery. Then second point, valid only up to calcium, because after calcium transition elements will come, so it will not satisfy this. So it is valid only up to calcium. After Newland's law of octaves, Lothar-Meyer came with another classification. Lothar-Meyer did not arrange the elements in increasing or decreasing order. He performed an experiment. I'll explain that experiment. Lothar-Meyer's classification. Fourth, Lothar-Meyer's classification. He plotted a curve between atomic volume and atomic weight. A curve between atomic volume and atomic weight. So he draw a graph. Atomic weight will come in horizontal line and atomic volume in vertical line. So he pointed some points in this graph. And after connecting these points, these points, lithium, sodium, potassium, rubidium, cesium, he saw it, these all elements are coming on crest of the graph. Crest, I will explain what is crest. In this graph, this is a crest and this downward point is trough. Okay, so lithium, sodium, potassium, rubidium, cesium on are coming on crest. Lithium, then sodium, potassium, rubidium, and if you continue, cesium will come on next crest. So crest is for alkali metals. Then trough, transition elements are coming on trough. Trough means these below points. So many transition elements are there, so I am not writing it here. Trough, transition metals. Then descending slope. And ascending slope. In descending slope, alkaline earth metals are coming. Lithium, in the lithium row, next element is beryllium. Then in a sodium row, next element is manganese. Then in potassium, next element calcium. In rubidium, strontium, like this. And in ascending order, halogens are coming. Ascending slope means which is increasing, going upward, this. Okay, halogens will come. And in descending slope, alkaline earth metal. Okay, halogens will come on ascending slope. Fluorine, chlorine, bromine. Then in, if we draw next, iodine will come. Now alkaline earth metal we have, right. Then ascending slope we have, right. Transition elements will come because so many transition elements are there, so they will come here because transition elements or transition metals come after calcium only, so it will come after this second potassium, calcium. Then Lothar-Meyer proposed that the physical property of the elements are periodic function of their atomic weight. Okay, so Lothar-Meyer was the scientist who said the physical properties of elements are periodic function of their atomic weight, because you can see the atomic volume and atomic weight. Volume is a physical property, not chemical property. But he also got failed. Failed. There was no practical use of this experiment actually. Use of this experiment. That's it. Lothar-Meyer's is completed here. Now Mendeleev's periodic table. This Mendeleev's periodic table is not much different compared to modern periodic table. So in the next video, we'll see the Mendeleev's periodic table and finding atom, finding elements, group, period, block. Okay. Thank you.